Hello everyone, welcome to another episode of our class. This is continuation of organic chemistry. And in today's video, we are going to be talking about naming. However, the naming is going to be about functional group. So we are going to be naming organic compounds that they have some functional groups. And that's going to be the lecture for today. However, before I proceed, I would like to recap. Recall from the golden formula I've given to you. I said whenever you want to name successfully, you need to get the prefix. After the prefix, you need to get the word root. And after the word root, after identifying the word root, of course, you need to get the suffix. And we said this suffix is divided into two. We have the primary suffix and we have the secondary suffix. You should be used to all this already if you have been following us. We said the primary suffix, this depends on the bonds. And we said the bond can be of three. It could either be a single bond. If you have a single bond, you end it with A-N-E. If you have a double bond, you end it with E-N-E. And if you have triple bonds, you end it with Y-N-E. Perfect. But you said for this secondary, the secondary suffix rather, as for this secondary suffix, in order for you to identify, you identify it by the functional group present. For you to identify the primary suffix, it is identified by the bond present. But for secondary suffix, you identify it simply by the functional group. And recall from our previous class, we've already discussed functional group. We said a functional group is just a group of atoms attached to a compound, and it determines the chemical property of that compound. So what are these functional groups? We have some examples of functional group like COOH. This guy can be written as C with and then OH like this. Whenever you see this compound, you are going to name, in the naming, you are going to call it oic acid. That's what you are going to add to it. You can see functional group like C double bond O with H. What do you call this one? This one can be written as CHO, and this one is called alkana, or you call it aldehyde. And if you want to name, you add Al to it. You can see compound like CO. So this CO, whenever you are naming, how are you going to name it? This CO is named as, if you have C double bond with O, this one is named as ONE. Why? Because this CO, that one is arcanon, or you call it ketone. Is it that you call it ketone or you call it arcanon? And please take note, people often have difficulty differentiating between this arcana, this CHO and CO. Please take note, if you have this CO at the end, it is definitely arcana. So if you are seeing CO, something CO with H at the end, maybe the beginning or the end of that compound, it is definitely arcana. Please take note of that. And because of this CHO at the end, I think I've told you before, there is a way we can differentiate with the use of reagent. This one gives a positive reaction with Tolin's reagent. Why? Because of that CHO, that terminal CHO. But see this CO, this one, this arcanone, it can never ever be at the end. It's always within a compound. So if you see CO within a compound, what is that one? It is going to be arcanone, or you call it ketone. But if you see it at the end, it is aldehyde, alkana. If it is within a compound, it is ketone compound. Does it make sense to you? All right, let's take another example. Suppose you have functional group, you can be presented with functional group like OH. If you want to name this, it's quite simple. Just add OL to it. You could be presented with functional group like COOR. This one is called ester compound. You call it ester compound. And this is acanoate. You add OATE to the compound you are naming. Suppose you have compound like CONH2. If you want to name this one, what are you going to call it? You just call it imide. What about if you have C with triple bond N? That one is also quite simple. What are you going to name this one as? You call it nitride. That is that. Now, let us quickly recap, then we take a compound and name. Recollect from what we've said in our previous classes. We said whenever you see any prefix, the prefix is simply any attachment. And we said word root is your longest chain. And note that the moment you are able to identify your longest chain, whatever is not part of the longest chain is going to be an attachment. Of course, you call it a prefix. And then you know your suffix already. It could be primary or secondary. Does that make sense to you? Now, let us quickly take a look at the golden rule as well. This is golden formula, then the golden rule. Then we go ahead and start naming. So what is the golden formula? The golden rule. The golden rule is you select the longest chain. Select the longest chain. However, the longest chain you are selecting, it must containing the functional group. So before you can identify or before you can say with confidence that, oh, this is the longest chain, the longest chain must contain functional group. The second thing is you also number. Remember that, right? That's the second thing you do. After the identification of the longest chain, the second thing you do is numbering. And how is the numbering done? You number by following the lowest locant rule. And how are you going to follow the lowest locant rule? You must ensure that your functional group is getting the least number. Your functional group must get the least number. It must get the least numbering. Please take note of that. Then the last thing is what? Alphabetical order. So these three are the major rule. If you can remember these three, of course, naming is going to be a simple thing for you. So now let us take an example of a compound, then let's name it. Then you see that naming is quite simple. So suppose you are given a compound like this. You have CH3, CH2, another CH2, then let's put another CH2, then you have OH. So what's the longest carbon chain? Of course, this straight chain is the longest carbon chain. So if you look at the longest carbon chain, is there any attachment? There is no attachment. If there is no attachment, what are you going to do? You just name it directly. So what is our longest carbon chain now? It is 1. You start numbering from here because the functional group is attached to this carbon. 1, 2, 3, then 4. So what's going to be? The word root is both. Now, after you've identified that it is both, you go to the next thing. What's next thing? This primary suffix. What's your primary suffix? The primary suffix here is based on bond, and there is no double bond here. Everything is single bond. So you add ANE to it. After adding ANE, then you go to your secondary suffix, right? What was your secondary suffix? The secondary suffix here is going to be the OH, the functional group attached to it. And it is attached to which carbon? Carbon 1. So you say 1, then OL. Why did I add OL? I've already said it here. Whenever you have OH, you put OL in that position. Do you understand this? Perfect. Now, the last thing you need to pay attention to is, if you look at this, O is here and E is here. These two guys, they happens to be the same thing. When I said the same, that is, the two of them are vowels. And whenever you have vowel letter, what are you going to do? You cancel the previous vowel letter. So you see this E, you are going to remove it from here. Whenever you are naming, then this is the right name, according to the IUPAC system of naming. Does that make sense to you? Good. Now you can jot down something. Let us take another example. But before taking another example, it occurred to me that some people might have forgotten our golden formula. So let me quickly help you to write out the golden formula here so that you can remember. Whenever you are naming, don't forget this. Whenever you are naming, the first thing is the position of the attachment. Position of attachment, or you can call it substituent, or you can call it the prefix. So once you identify the position, then the next thing is you go ahead and name your prefix. That attachment, you name it. After you've identified that attachment, then you name your word root, the longest chain. After naming your word root, then you can go to your primary suffix. Then you go ahead and name your secondary suffix. That's how to name. Now, suppose you have a compound like this, and then we are asked to name this one. So if you want to name this now, how are you going to name? Suppose they ask you to name. It's very simple. Remember the first rule. The first rule is identify your longest chain. What's our longest chain? Of course, this is going to be the longest. You can see now, quite simple, right? And anything that's not part of the longest chain, what are you going to call it? Yes, attachment. So here is an attachment. Why? it is not part of the longest chain. And this attachment is going to be called what? Your prefix. This prefix, what is the name? It has one carbon, so you call it methyl. Perfect. Interesting. Now, after you've identified all this, what's the next thing? You go ahead and then number your carbon. Of course, you call this one carbon 1. Remember that you give the priority to the place the functional group is located. But you don't number from this is not the first one because this is the first carbon. Take note of that. That's where one of the places students often make mistake. So please take note of that. This is, even though it is COOH, this C is carbon 1. Then this is going to be carbon 2. This becomes carbon 3, carbon 4, carbon 5, and then this is our carbon 6. Does that make sense to you? Now let us go ahead and name. If you want to name, what are you going to do? Position of the substituent. Where is the position of the substance? Carbon 4. So you say 4. What is at that fourth position? You go ahead and name your prefix. And the prefix is methyl. After identifying methyl, the prefix, you go ahead and name your word root. Your word root. I said word root chain. This is word root. Now remember, the word root is the longest chain. So after identifying your longest chain, that is your word root. And what's our longest chain here? 6 carbon. What are you going to call it? You call it hex. Good. Now, after seeing X, what's the next thing? The secondary suffix. What's our secondary suffix? That one depends on the good. The primary suffix depends on the bond. Secondary suffix on the functional group. So let's name the primary suffix first. Which bond do we have here? We only have single bonds. So what are you going to say? A-N-E. Then after that, you go ahead and name your secondary. So what's your secondary suffix? It is what? Perfect. It is this guy, acanoic. And if you have acanoic, what are you going to name it as? OIC acid, oic acid. So the oic acid is at which position? Position 1. So you just say oic acid. And this is the name of this compound. However, remember, we have O here and we have E here. What's going to happen? The O is going to cancel E. So remove E, and then that is the name of this compound. You can see that it's quite simple, right? Let us take another example so that's going to make much more sense. Now, this compound is presented to us and we are asked to name. But this compound is in form of bond line. So this compound we want to name here is quite simple. Yes, quite simple and quite straightforward. All you need to do is follow through the course and then you are going to say, just follow me as I'm going to name it now. Now, you see this compound here. I want to believe you still remember how to the bond line to represent it. The bond line, whenever you have bond line, what does that mean? I want to believe you still remember. Each of the points is representing carbon. So you see each point that we have here. What is there? Carbon is at those points. What about this? You know, carbon is not at this end though. Why? Because there is OH attached to it already. Do you understand? So how many carbons do we have now? So that it's going to be clearer. Let me write it out. We have carbon here, carbon is here, carbon is here, carbon is here, carbon is here, and there's one carbon here, and even here. Those are the carbons we have. Now the next thing is, if you want to name, you know that you need to identify your longest chain. I'm very sure that it's going to be tempting. You might probably want to say that, oh, this is going to be our longest chain. But of course, it is very, very wrong. Why? Because you have triple bond here. Your longest chain must contain your functional group and that special bond. Do you understand? That multiple bond must be there. So if I want to identify my functional my longest chain now, what's it going to be? Yes, you are correct. So it's going to be like this. So this is our now this is the longest chain. Now after you've identified your longest chain, what is the next thing? Whatever is not part of the longest chain is going to be what? An attachment. So that means this guy here like this old guy is an attachment. And what is this old guy? This old guy has how many carbon? It has 3 carbon. So you see it is what? Propyl. I want to believe you understand this. Now after that, the next thing is the longest chain has how many carbon? Can you see? Of course, it has 4 carbon. And how are you going to number? You number from the functional group. This is the functional group, but there's no carbon with the functional group. So you start numbering from here. This is 1, 2, 3, and 4. So our longest chain has how many carbons? 4 carbons. So naming is going to be a piece of cake now. Now let us go and start naming. What is the first thing? The position of the substituent. What's the position of the substituent? This is the substituent. Is at position what? Position 2. So you just say 2. What's at position 2? The prefix, that substituent, and it is propyl. After this, you go to your word root. How do you recognize your word root? The longest carbon chain. What's the longest carbon chain here? It is 4 carbons. So you say both. After that, the primary what? Primary suffix. How do you get your primary suffix? We said it depends on the what? Bond. But we have a special bond here, which is triple bond. So what's going to be? We call it YNE. Triple bond represents what? YNE. And this YNE is at which position? It is between position 3 and position 4. So which one are you going to take? You take 3 in preference to 4 because 3 is lower than 4. So you say as position 3, YNE is there. Then after that, you can now go ahead again and name your functional group. And that is all. So where is the functional group present? It's present at what? Position 1. So 1 then OL. And that is all. However, before you drop your pen, remember you have OA and you have EA. What's going to happen? What's the consequence? Two vowels. O is going to cancel the E. And then this is just going to become, you add N here. And this is the name of this compound. You can see that it's quite simple and straightforward. Let's take more examples so that the thing is going to be very smooth for us. So suppose we have a compound to name. It's actually quite simple to name this. This is also a bond line representation. And I want to believe you should remember, whenever you have bond line representation, what does that translate? Each of these points is representing carbon. So we have carbon here. Carbon is here, carbon is here, carbon is here, carbon is here, and carbon is here. Even here. Do you get it? Perfect. So even this place, so there is also carbon. I want to believe you know that. And then there is functional group here. You see this carbon. Look at this place. This is carbon with 0. What does that mean? This carbon with O. What does that mean? It is what? Can you say it out? It is ketone. Why do I call it ketone and not akana? Why is it ketone? Why is it akanon and not akana? Because this guy is not at the end. Suppose it's at the end, you will just call it akana. So at the end of the name you hear, you put AL there. Do you understand? But this one is what? A ketone. Or you call it what? Acanone. And remember, a ketone has negative reaction with Toluene's reagent. It is aldehyde that has positive reaction with Toluene's reagent because of the terminal. That's just by the way. Now let us quickly go and name this guy. For us to name this guy is quite simple. All you need to know is first rule: select your longest chain. Abby, you should be able to select the longest chain. Yes, if you are thinking what I'm thinking, this is going to be the right longest chain. Like this. Why? Because all the functional group, even the double bond is there. So that is going to be our longest chain. After identifying your longest chain, whatever is not part of your longest chain is going to be regarded as what? Perfect. You regard it as substituent. So here is our substituent. And this substituent right here, what are you going to call it? You call it a prefix. And what is this prefix? It has 3 carbons. So that's going to be what? Propyl again. Do you understand? Now you need to number for you to know the position in which this substituent is. So for us to number, you number with rest in such a way that your your functional group will get the lowest number. So this is 1, this is 2, this is 3, this is 4, this is 5, right? And this is 6, then this is 7. Sorry. This is not, I made a mistake here. You should have corrected. Oh, there's no way you could. This is going to be ethyl. Do you know why it is ethyl? This carbon here, it is here. It is this carbon. It's not part of it. So this is this and this is the attachment. Good. So it is now ethyl. So now we can go ahead and name it. So we can see that this ethyl is attached to which position? 5th position. So if I want to name now, so it will just be position of the substituent. And what's the position of the substituent? 5th position. What is attached to the 5th position? The substituent, that the prefix. And what's that prefix? We call it ethyl. And after that, you go to your word root. What's your word root? The longest carbon chain. What's the longest carbon chain? Hept. And after that, you go to your primary suffix. What's your primary suffix? Of course, you have double bond here. And the double bond is between what? 6 and 7. You take 6 over 7 because 6 is smaller than 7. So you say 6. Then E and E. After that, what was the next thing? What was the next thing? The secondary suffix. And what is the secondary suffix here? It is the acanone, which is at carbon 2. It is the acanone at carbon 2. So you just put O N E. But remember, you have a vowel here. So the vowel is going to cancel this. So this becomes what? Perfect. And that's the name of that compound. I hope it is very good. we still have further examples to give so that this thing is going to be crystal clear. So let us get another example for ourselves. This is the compound presented to us, and it is required that we should name it. Of course, how are we going to name this? This is quite simple, right? So for us to name it, oh, there should be a double bond here in order to make it look more attractive. Let's put one bond here. So if you want to name this now, how are you going to name? You know the rule already. Select the longest chain. Now, if you are to select the longest chain has to contain the perfect. It has to contain the functional group. So here is our longest chain. So the longest chain is like this. Do you get it? Now, after selecting the longest chain, what's next thing? You're going to number. And if you want to number, you number in the sense that the longest chain, the functional group will take the least number. And I want to believe you still remember that each of the points contain carbon, right? Interesting. If you still remember that. Now, this is carbon here. Carbon is here, carbon is here, carbon is here, 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 even here, there's a carbon. Does that make sense to you? Let me even put it so that you don't get confused. So we know that we need to clear all our doubts. So you can see that you can see where those carbon are present. Now, after recognizing where the position of each of the carbon, now what is the functional group if I ask you? You see this place, there is C, then double bond O, then here, what do you have? OH. What does that look like? It looks like ethanoic. Remember COOH. I want to believe you get that. You get the scope, you get the gist there. So ethanoic, sorry, I said ethanoic, arachanoic. Because of COOH, what is it going to be? It will be arachanoic acid. COOH represents what? Arachanoic acid. So now let us quickly go and name. But before we name, if you look at the longest chain, there is an attachment here. And this attachment is having only one carbon. So you call it what? Methyl. Even we need to number. How are you going to number? You number from here. This is carbon 1. This is carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. Does that make sense to you? Now, after the numbering, then we can now go ahead and name. So if I want to name, remember how to name. The first thing is what? Position of the substituent. What's the position of this substituent? Is at carbon 3. So you say 3. What's at that 3? It is that substituent, the prefix. And the prefix is what? Methyl. After that, you go ahead and name the word root. What's our word root? It is 7. 7 carbon chain. So you call it heps. After that, you check again this primary suffix. What is the primary suffix? Of course, there is a double bond because of this guy I put here. So that is a double bond. Let me highlight it with black ink. So you can see that extra bond. So what are you going to call? You call this ENE, but this ENE is between carbon 4 and carbon 5. So since it is between carbon 4 and carbon 5, which one are you going to take? You take 4. You say 4 ENE. And after that, the functional group. The functional group is as well carbon 1, oic, then acid. Perfect. Perfect. But to make it extremely perfect, super perfect, you need to remove this E. And now that is the name of that compound. I want to believe it is very clear. Now let us now go to some special cases. Special cases. So these special cases can actually be presented to you. Yes, it can be presented to you. Let us take those special cases now. So now look at this compound given to us. It's quite simple, but there are things you need to note before you can name it. But to make it easier for ourselves, let us convert this one into, because this is a condensed formula, let us convert it so that it's going to look more attractive and more meaningful. So this one, you see these guys inside bracket, it is representing attachment. So you can see the way I've attached them. So it is attached. The two are attached to this carbon. And after that, we have CH2. And after that, we have COOH, which is the functional group. Now, for us to name this is simple, but it is logical. Look at the logic there. If you look at it critically, you will identify that we have functional group here, COOH. But don't be deceived. There's also another functional group here, which is what? OH. So that is the issue. Because you have one functional group here, we have one functional group here. So there is another rule that we need to know before we can name this compound. And what is that rule? Before we can name this compound, let me give you one small rule and let me write it here for you. So that rule is going to be guiding us whenever you have two functional group. Because when you have two functional group, it is an issue. So you must know that rule so that you will not have any issue during the course of your naming. This table here shows you the functional group in order of priority. the one written at the top here is the most prioritized. That is, you give higher priority to it. Please take note of that. So this is in order of priority. This is number 1. You give higher priority to it. This is number 2. This is number 3. This is number 4, number 5, and then this is the least prioritized. Please take note of this order of priority. So whenever you give priority to one, the other one that is less prioritized is going to be an attachment, a prefix. You can see I've written it here. The higher priority is here and lesser priority. So the one that is lesser prioritized is going to be a prefix. But the one that you have given priority to is going to be suffix. Which suffix? The secondary suffix. This one is not going to be a suffix again. This one, what are you going to call it? You turn it to a prefix. Do you understand? So now let us take this example so that it's going to be clearer. Look at this example. We have two functional groups. You have OH and you have COOH. The question is, which of the two would you give priority to? I've given you the table here. So you can see that COOH is leading the table. So that means it has highest priority. You give more priority to COOH over OH. So since you are giving priority to it, that means your naming is going to be around this COOH. What does that mean? If since you are giving priority to this, our longest chain, you can take this one. Because remember, your longest chain must, yes, it must cover your functional group. So after you have taken this one as your longest chain, remember that whatever you have that is not a component of the longest chain, what are you going to call it? You call it an attachment. So by default, this two becomes our attachment. What's the name of this one? Yes, it is methyl. And what's the name of this one? OH. What do you want to call it? You want to call it all? No, it's no longer all. You will not call it all. Look at the table. So since you are not going to give it priority, since it is lesser prioritized, it's going to turn to prefix. And if you want to turn it to prefix, what would you call it? Hydroxyl. So this one becomes what? Hydroxyl. Do you get the scope? Perfect. Nice. Now, if you want to name now, you have been able to identify your longest chain. After identifying your longest chain, what's next thing? You number, right? So if I want to number, you number, remember that you number in such a way that your functional group will take the least number. So this is going to be carbon 1, carbon 2, carbon 3, and carbon 4. Does that make sense to you? Now, since I have been able to identify the longest chain, and I've been able to identify my prefixes, because we have two prefixes here, so we can go ahead and name. So if I want to name, how are you going to name? Position of the substituent. And what's that substituent? The prefix. So what's the position of that substituent? Of course, we have it as what? Position 3. But between methyl and hydroxyl, which one comes first? H comes before M, right? So that means I will first say hydroxyl. After that, we still have another prefix that we need to mention, and that is still at position 3. What's the name? It is methyl. Sorry. So methyl 2 is at position 3, so we need to write it there. After that, we can now go ahead. You are done naming the prefix. You go to your word root. What's the word root here? Of course, it is 4. Since it is 4 carbon, boots. You call it boots. After the boot, you go to your primary suffix. What's the primary suffix here? What was it? It depends on bond, Abi. And which type of bond do you have here? Single bond or true. So it becomes A-N-E. Then after that, hyphen. I want to believe this is still making sense. After hyphen, your secondary suffix is at position 1, carbon 1. Look at it now. It's at carbon 1. Then what do you call it? So you call it oic acid. I made a mistake here. So sorry. So it is oic, not oic. It is oic acid. So we call it oic acid. And that is the name of that compound. But remember, this O and E cannot coexist. So what is going to happen? You are going to remove E for that O. And this is the name of this compound. So you can see now, whenever you are given two functional groups, I want to believe you can name it. Can you? All right, let me give you another example so that this thing is going to make much more sense to you. Now, here is another compound given to us. We are required to name this compound. Please take note. Most of those two functional groups that you are going to be given by functional group, most of them, not all, but most of them will contain this oic acid. And you know that you always give more priority to oic. So even if you cannot put this table in your head, just know that if you have any functional group that is dragging with oic, oic will always get your priority over the other one that's dragging with oic. Do you get the oic I mean? This acanoic acid. So we have two functional group here. You can recognize, you can identify them. This is one functional group and this is one functional group. What's the functional group for this one? Acanoic acid. And what about this one? This one is what? Ketone, acanone. And I want to believe you still remember why it's ketone, because of CO, the CO double bond. Now, for us to name, how are you going to name? It's quite simple, right? All you need to do is the first rule of naming. Identify your longest chain. And here is our longest chain. Simple and straightforward. Number 2 is numbering. You number in such a way that your functional group, the prioritized functional group, will get lower, will get a lower number. So this is 1, this is 2, this is 3, this is 4, this is 5, and here is our 6th carbon. So since we have been able to identify all those, then we can now go ahead and name. But remember that since you have been able to identify this, you have another functional group. This functional group that you have here, what is it going to be? Of course, it's going to be an attachment, a prefix. And whenever you have your CO to be a prefix, this is the CO. When CO is a prefix, what's it going to become? You call it oxo, because it's going to be a prefix now and it becomes oxo. And this oxo is at which position? 5th position. So now let us go ahead and name this carbon. You should be able to name. You can pause the video and make an attempt. So this is going to become 5-oxo, right? Oxo what? You have named your position, you have named your prefix. Now go ahead and name your word root. What's the word root? The longest chain. It contains 6 carbons, so you call it hex. After that, you go to your primary suffix. What's your primary suffix? Depends on bond. Look at it. We have a double bond right here, hanging here. So since there is double bond, what are you going to call it? You call it ENE, right? But this ENE, this double bond is between which carbon? Carbon 3 and carbon 4. You take 3 over 4. So this one becomes 3. Then ENE. I want to believe that is clear. Good. After that, then you can now go to your secondary suffix. What's our secondary suffix? Oic acid, which is at which position? Position 1. So you call it 1-oic acid. And that's the name of that compound. But don't forget, this E will need to be, you need to get rid of that E. Why? Because of those two vowels coming next to each other. So that is the name of that compound. You can see that naming of organic compound is quite simple and straightforward. Let us take probably 2 more examples before we call it a section so that we can cement the knowledge very well. Look at this question. In the compound given to us to name, you can see that it has 2 functional groups. But there is something here that you need to take note of. Don't fall ahead, don't fall victim. This functional group and this functional group, they are the same. So which one are you going to give priority? Of course, they are the same. There's no need for you to prioritize one over the other. So what are you going to do here? Identify your longest carbon chain. Of course, the straight chain is the longest carbon chain. The second thing is what? Number. But if you want to number here, you need to number in such a way that your functional group will get a lesser number. And if you look at it, this functional group are skewed to this side. So that means if I want to number, I need to number from this side so that it can follow the lowest locant rule. So this becomes 2, 3, 4, 5, and 6. Now, after identifying that, is there any substituent, any prefix? No prefix. So let's go ahead and name. So that means there is no position, there is no prefix. Let's go ahead and talk about our word root. So what is the word root here? Of course, is there any word root here? The word root is the longest carbon chain. And what's the longest carbon chain? 6. So you could just call it X. After that, the next thing is your primary suffix. What's your primary suffix? Is there any double bond? Don't count this as a double bond. This one is a functional group. And this one too is a functional group. Those two are not double bond though. They are functional group. Do you understand? So what are you going to call it? Since everything is single bond, it becomes what? ANE, exam. Good. After that, you go to we have named our primary suffix. The primary suffix is because of everything contains single bond, so it becomes ANE. Now the secondary suffix. What's going to be the secondary suffix? Each of the functional group. And how many functional group do we have here? We have one functional group right here, lying over here. And we have another functional group lying over here, right? So this functional group, what is it? Of course, it is ketone. You can see C double bond O. So this is ketone. And if you want to name it, you put ONE. This is also a ketone, ONE. This functional group, where is it? It's at position 2 and position 4. So you write 2, 4, then hyphen again. What is that position 2 and position 4? Ketone. And ketone it ends with what? ONE. But because you have 2 functional groups, 2 ketone, you put what? Di. And remember, is this E? Are we going to get rid of E? No. Because what is coming after the E is what? Consonant. Suppose it is vowel, then you are going to get rid of the E. And that is that. You can see, naming organic compound is quite simple and straightforward. Or if you are yet to follow us, please follow, subscribe, hit the subscribe button so that you can get notification whenever we post any new content. Now let me give you a question. Then after the question, I will give you another naming that you need to note. Yes, a naming of ester compound. It's one of part of the places your exam questions could be presented. Examiners like to ask questions on ester compound because ester compound is quite simple, but it is very easy for students to make mistake. So here is your first question. Please name this compound and drop your answer in the comment section. Let's see who is going to get it right and who is going to get it wrong. Then name this compound as well. You have H here, then you have double bond and O here. Name this compound and let's see your answer in this comment section. So up next is naming of ester compound. Now let's discuss naming of ester compound. Ester compound is a product of reaction of alcohol and alkanoic acid. So whenever you react alkanose together with alkanoic acid, and remember alkanoic acid can also be called carboxylic acid. So the reaction of these two give rise to ester alongside with water. But we want to dwell on ester compound today. Now naming of ester compound is quite simple because the general notation for ester compound goes as thus: RCOOR. But in order to tell you that this R and this R are not the same, though we know that generally R represents alkyl group, but the alkyl you are going to have here and the one you are going to have here might be the same and might differ at times. So in order to show you that it is not compulsory or it's not every time that they are going to be the same, so you are going to see it in your textbook, they will put prime at the top of this R. That is to show you that the alkyl at the beginning and the one at the end does not necessarily have to be the same thing. Does that make sense to you? Good. So if you want to name, how are you going to name? The first thing is you name this alkyl first, give a space, then you name this one. Do you understand that? You name this R first, this R prime first, then you give this other one. For example, suppose you are given a compound like CH3, CH2, CH2, COO, then you have probably CH2 and then CH3. Suppose it is a compound you are given and you are asked to name it. How are you going to name? It's quite simple. You know that this place here represents your what? R prime, which is the alkyl, which is going to come first. And this is going to come second. Or you can see that this is like the parent's name. And this one is like the attachment, the prefix. So if I want to name now, you know that we always give the prefix, we always name the prefix first before the parent's name. So what is the name of this prefix, this attachment? It has two carbons. This is carbon 1 and this is carbon 2, right? So how many carbons do we have there? Two carbons. You call it what? Ethyl, because it's an attachment, an alkyl group. Then you name the parent. The parent has how many carbons? This is carbon 1, carbon 2, carbon 3, and carbon 4. How many carbons do we have here? 4 carbons. What is going to be the name? You leave a space. Then you call it boot. Because everything here is single bonded. So it's going to be what? AN. Then OATE. Why do you add OATE to it? Because that is the functional group of alkane. We always call it alkanoate. I have already said that earlier. So if you check the earlier video, you see there earlier in the video, it's part of the thing we've said. Does that make sense to you? Suppose we have an example like this. What's going to be the name? Remember, anything after your COO, everything after it, what are you going to call it? Is your alkyl, your R prime, and this is your what? Your parent chain. So if I want to name now, what is this alkyl? The alkyl has how many carbons? 1, 2, 3. There are 3 carbons here. So you call it what? Propyl. After that, before you name your parent chain, you leave a space. The parent chain has how many carbons? This is the first carbon. The functional group carbon is part of the carbon. Carbon 1, carbon 2. So this becomes what? 8. Because everything here is single bonded, it's going to be what? Ethanoate. Do you understand? Why do I say noate? Because of the functional group. So you can see that naming of alkyl is quite simple. However, they can now decide to go a bit further for you. So suppose you are given a question like this and you are asked to name. You can be presented question in form of a bond line. They can give you bond line representation. Question that's like this. You don't need to freak out. all you need to do here is just follow a simple rule, and of course you'll be able to name it. Okay, let's give ourselves this kind of. So when you are given something like this, let me quickly give you the gist. The gist here is, remember what is the general formula, the general notation of attenuate? We said it is RCOOR. Do you know that we can still decide to write this in formula form? If I want to show you the skeletal structure, it's going to look like this. R, then you have your C. This C is double bonded with one O and then single bonded with the other O. You know that how many O do we have here? Two. The one that follows the C and the one that is and the latter one. So this first one is double bonded with O and the second O is single bonded to O. Then you have your R. So whenever you want to name, suppose it is given to you like this. Follow this simple. You don't need to follow big rule or disturb yourself. All you need to do is follow this simple rule. Identify the O that is singly bonded, like that has a single bond with the C. Once you identify the O, you can see from this formula, this is the O that has a single bond. This other O here has double bond. So identify the one that has single bond. Then name it like this. That is going to be your alkyl. Then identify the O that has double bond. So you can see that here, this is the O that has double bond. Then you are going to name it like this. And this is going to be your alkanoate, the parent. Does that make sense? So that it can be clearer. Now let us use this example to simplify the rule. So if you look at it, remember what we have said in our previous classes that each of the points represents what? Carbon. So there's a carbon here, here is a carbon, here is a carbon, even here is a carbon. Of course, we have carbon here, we have carbon here. How about this place? No. What is occupying this position is what? Oxygen. So there is no O. So there is no carbon here. Now, I've told you that the simple rule you need to follow is what? Identify the O that has a single bond. And where is the O that has a single bond? Of course, this is the O that has a single bond. You can see it's just single bond. So it has a single bond that is existing between it and carbon. Once you identify the O, what did we say? We say that you should name it like this. And once you name it like this, what is that going to represent? Your alkyl group, the side chain. Then whatever you have left like this, from the O that has double bond, name it like this. This is going to be your what? Parent chain. So you can see that it's quite simple. Now go ahead and name. This one that has single bond, if you go like this, how many carbon do you have? You have carbon 1 and carbon 2. What are you going to call it? Of course, you call it ethyl. Leave a small space. Now go to the one that has double bond. Here is the one that has double bond with carbon. Now count from here. 1, 2, 3, 4. What are you going to call it? Of course, you call it butanoate. Does that make sense? In case it is not very clear, let us quickly name this compound too. Now, can you see this compound? What did I tell you? Identify the carbon that has what? Single bond. But where are the carbons? Of course, each of the points here represents carbon. Don't ever forget that. There's a carbon here, there's a carbon here. Of course, here and here, we have carbon. Now, identify the carbon that has single bond with O. Or let me say, identify the O that has single bond with carbon. And here is the O that has single bond with carbon. You can see that it's quite simple, right? Perfect, interesting. Now, since you are able to identify this O, what are you going to do? From this O that has single bond, name like this. That's going to be your side chain. And how many carbon do we have here? 1, 2, and 3. This is carbon 1, carbon 2, carbon 3. So you call it what? Propyl. And then from the O that has double bond, where is the O that has double bond? Here is the O with double bond. You can see this guy is double bond. So from here now, count like this. And that's going to be your parent chain. I want to believe it is clearer now. So 1, 2, 3, 4, 5, 6. What are you going to call it? You leave a small space and then call it what? Hexanoate. Does that make sense to you? All right, let's take more examples. What if you have substituent? What if you have another attachment on the attachment? How are you going to name? Let us quickly go to that example. Now, suppose this is the question you are presented with and you are asked to name. Of course, simple. All you need to do is identify the oxygen that has a single bond with carbon. And where is the oxygen? Here is the oxygen that has a single bond with carbon. But am I going to name it this way? If you are naming it this way, you can see that there is oxygen with double bond with carbon here. So that means naming it in this direction is very, very wrong. So instead, how are you going to name? Of course, you go this way. Does that make sense? And once you name like this, what is this going to be? This is going to be like your side chain. Then you name like this, and this is going to be a perfect. Does that make sense? Interesting. And remember that each of the points, what do you have there? Of course, there's carbon at each of the points. So let us put the carbon in order to avoid any form of confusion. So I want to believe it's quite simple for us to name now. What are you going to do? You go ahead and name. How many carbon do I have here now? We have carbon 1, carbon 2, carbon 3, and carbon 4. And that is going to be what? Butyl. But if you look at this butyl, look at it very well. There's an attachment on the butyl itself. So this is an attachment. And what are you going to do? Of course, you name your attachment. You know how to name attachments, right? This attachment is at which carbon? Number your carbon. This is your carbon 1. The one closer to your site and to your functional group. Carbon 2, carbon 3, and then here is carbon 4. Now, after numbering, this attachment, which is methyl, it is attached to which of the carbons? Of course, carbon 3. So you say on the third carbon, methyl is attached. Does that make sense to you? Do you understand it? Let me wipe this off and write it very well. So we have on position 3, we have methyl. And this methyl is still part of what? Butyl. Do you understand that? Then after naming this, then we can go ahead and name this. Now, if you want to name this contains how many carbon? Carbon 1, carbon 2. Remember, before you name your alkanoate, you leave a space, and this is going to become what? Ethanoate. It's quite simple, right? Now, let's go to this example. Suppose you want to name this second question. It's very simple. The first thing is identify the carbon at each of the points. So we've identified the carbon now at each of the points. After that, what's the next thing? Look for the O that has a single bond with carbon. And here is the O. How am I going to name it? I name it this way because naming it the other way is going to, there's double bond of this thing there. Do you understand? So now for us to name this one, it's quite simple, right? What are you going to do? This one has carbon 1, carbon 2. So how many carbon do we have at the side chain? It's just 2 carbon. So what are you going to call it? You call it ethyl. Why is it ethyl? Because it has just 2 carbons. Then after that, we can go ahead and name the other one. So this other one now, it has how many carbons? 1, 2, 3, 4. But look at it, there's an attachment here. And what's the name of this attachment? It has just 1 carbon. So the attachment here is what? Methyl. So we want to go and name this alkanoate, this parent. And remember, before you name your parent, you leave a space. But this parent has an attachment too. And the attachment is at position where? Position 2. So you leave a space and then write the attachment. Methyl is attached to what? 4 carbon compound, which is what? Butanoate. You can see that it's quite simple. Perfect. Now, let us go ahead and name this one. You can pause the video and make an attempt. So once you make an attempt, drop your answer in the chat box. Let's see if you are correct. But in case you are still looking at this or you are done making your attempt, now let us name it together. So this one now is the point where you are going to cut, right? But remember, at each of the points, you have carbon, 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 and carbon is there. Now you are going to name it this way. I want to believe you know that. And once you name it this way, this is going to be like your prefix. And what is this? It is 2 carbon, so it's going to be ethyl. After you've named your ethyl, what is the next thing? You go ahead and name this one. And this one has how many carbon? Of course, we have 3 carbons here. 1, 2, 3. And that's going to be what? Propanoate. Very correct. Propanoate. However, we have an attachment here. And what's the attachment? OH. OH is a functional group. But remember that in order of priority, ester compound have priority over OH. OH is down in the distance. Remember, I gave you earlier. So OH, since it's going to be a prefix now, it's not a priority. It's not going to be our suffix. Rather, it's going to be a prefix. So that means this OH, you are going to call it what? Hydroxy. Does that make sense to you? And this hydroxyl is at which position? Second position. So you go ahead and name your parents now. You see that on the parent, so second position, we have hydroxy. Then what is the parent itself? It is what? Propanoate. So for you to name, it's quite simple to name. All you need to do is practice, practice, practice. The more you practice, the better you become. Remember to like, share, subscribe, and follow so that you can get notification whenever we post any new content. Follow us for more tips. This is IGSCE Academy. We meet in our next video. Bye for now.